This is Australia, a land of remarkable contrasts. It is unique among Western countries in that it combines a stable and advanced society with a vast and empty hinterland. Back in the 1960s, these factors led to Australia partnering the first European and British launch programs as they joined the race into space. In 1967, Australia became one of only a few countries to successfully design, build and launch a satellite. Today, Australia is once more qualified and competitive in a range of space-related technologies and research. A coordinated national program is underway to develop a new generation of ambitious space projects.
Well, in this particular optical layout, we could start folding the optics around this point here.
And how will that fit into the design?
Well, that's the primary mirror, which was shown down here. If we fold it here, then we can start compacting the prism down, and you can see that that will shorten this region here.
Several instruments are being developed to fly on an Australian scientific satellite, scheduled for launch in the early 1990s. A key instrument will be a unique shortwave infrared detector, based on a 32 by 64 pixel CCD. These VLSI chips have been designed and built in Australia, and will have applications in industry, astronomy and medicine, as well as remote sensing of minerals. An airborne imager version has been developed for detecting minerals, and linear arrays of the detector are being tested for space application.
04740.
Australian researchers have become world leaders in the interpretation and enhancement of satellite images, particularly for mineral exploration. This has been essential because of the unique signal characteristics of Australia's ancient geological landscape and the immense distances in the unpopulated outback. The tyranny of distance has also made Australia one of the world's greatest users of satellite images for agriculture, oceanography, and cartography. The expertise in using remotely sensed images has given Australian scientists many insights which are valuable in the design of space instruments. The along-track scanning radiometer, for example, is a third-generation infrared scanner, jointly designed by Australian and UK scientists. It is to be launched aboard Europe's ERS-1 in 1990. The instrument will be able to measure sea surface temperatures to within 1/4 of a degree, valuable in predicting climatic phenomena such as El Niño, droughts and tropical cyclones. Australian technicians qualified by ESA are building the ATSR Digital Control Electronics near Adelaide. And Australia will develop software and carry out calibration and validation tests for the ATSR. Experience in developing these and other space instruments will be applied to the design and construction of Australia's next generation of AUSAT communication satellites. The first two were launched in 1985, and while wiring harnesses and some other components were fabricated in Australia, the satellites were largely made in the United States. But such is the revival of Australia's space industry that a significant percentage of the new generation of satellites will be locally made. Executives from Australia's major aerospace companies are tendering for over $100 million worth of contracts.
We are strongly committed to increasing Australian industry participation.
AUSAT has solved communication problems which are unheard of in most other countries. The provision of broadcasting, telecommunications, and even medical services to people often hundreds of miles from their nearest neighbour. Australia is one of the world's largest users of satellites for international telecommunications. The expertise needed to design and manufacture systems such as this OTC Intelsat ground station have come from another space technology in which Australia has led the world: radio astronomy. For over 25 years, radio telescopes such as the 64-metre dish at Parkes have given Australian scientists an unparalleled understanding of the southern sky. Australia's expertise in radio astronomy has been adapted to serve major space programs. The Parkes and other dishes have provided an essential ground link for missions such as Apollo, Voyager, and Giotto. This experience has led to the design, construction, and testing of the world's most efficient high-performance antenna feed horn systems. The feed horns are integral to the next generation of Australian space observatories. One such observatory is the Australia Telescope. It will be a synthesis instrument, combining an array of 6 movable antennas with the Parkes instrument and another at Siding Spring. They will have the combined effect of a single dish 300 kilometers in diameter. The synthesis concept is also being extended to space-based astronomy. Australia is involved in joint studies with European and Russian agencies to produce orbiting radio telescopes to explore the most distant known reaches of the universe. This is the Australian Large Format Photon Counting Array, the largest intensified CCD detector ever built. It was originally developed for ground-based optical astronomy, but is now the centre of another space-based mission, Project Endeavour, an ultraviolet telescope experiment currently being built by Australian engineers and scientists. It uses technologies originally developed for the Starlab project and is due to be launched by the end of the decade. The Endeavour project is designed to test systems which could be used on the European Space Agency Lyman telescope, due to be launched in 1992. Much of Australia's aerospace technology has evolved from the policy of encouraging self-reliance in defence systems. The unique Jindalee over-the-horizon radar system is a technological first. It uses the ionosphere to give accurate surveillance over a radius of 5,000 kilometres, essential to monitoring Australia's vast unpopulated coastline. The government offset policy means that major defence items, such as the FA-18 Hornet, have a high proportion of local manufacture and assembly. A technological capacity of the highest order has been developed to meet these demanding contracts. It is a capacity which makes Australia an attractive potential collaborator in joint space programs. Now, a new proposal gaining international interest would give Australia a quantum leap into the 21st century. Cape York, the northernmost point of the island continent, has been proposed as the world's first commercially run international space launch base. Australia is once again space qualified, and the money and resources are available for a fast, expanding industry.